All right, guys, welcome to lesson 4.3. We're going to continue talking about the limit definition of a derivative, but today I'm going to be giving you guys a different form of that limit definition. And why would I do that? If we have one form already, why do another one? Well, to tell you the truth, I don't really think there's a good answer to that. But the fact of the matter is that they want you to know both, so I'm going to teach both. But they essentially accomplish the same feat. So let's go ahead and without any further ado, we're going to jump in and we're going to do this other form of the derivative. Now, you're already familiar with this one. This is what the standard one that we're already familiar with. Oops, my bad. Okay, and that's the one that you guys are already familiar with. Well, today I'm going to give you guys a different one. It's really not even that much different, but yet it does cause some differences to arise, so it's something we'll definitely need to spend a little bit of time on. It wouldn't just come naturally apart from that. So let's go ahead and see what we can do. All right, so we're going to do this one the way we did the other one. We're going to have you guys start off by copying down this picture here really quick. So if you need to pause the video, now would be a good time for that. All right. So here we go. So last time I called this point here x and f of x, but this time I'm going to call it c and f of c. I'm just laughing at myself because we're really just changing one letter there, right? But it'll make a little bit of a difference, you'll see. And so if I call that point c f of c, then the x value here is c and the y value is f of c. All right? This point up here, we're going to call that the variable point, so it can change. C represents a constant. It's fixed. It's not going to move. That point's going to stay right where it belongs. But this point up here is going to be my variable point. It can move. So I'm going to call the x value just x because it could be any number we want, and the output can be x. So that one does not represent a constant. It represents a variable, so it can move. And that's why whenever we did this before, we took this point and we can slide it around and change the x value, right? So there's the other point, x comma f of x. And therefore, this distance over here is that x value we're going to call x, and this height we will call f of x. All right? Now, before, I called this distance here delta x, but if you might recall, there's another thing that we can call that. We can also call that x minus c, right? Just the distance between those 2 points. You take the bigger one, x. I know it's bigger because it's to the right. And you subtract from it c, the one that's to the left of it. So we'll call that distance there x minus c. And then to find this distance here, we have f of x minus f of c. And so my difference quotient is going to look like this then. We have y2 minus y1 over x2 minus x1. And that looks a little bit even more familiar. All right? So now let's go ahead and actually start doing the limit though on this. So you guys know what I want to do is I want to take this point and I want to slide it down, right? So what's happening there? Well, I'm letting this point get closer and closer to this point. In other words, I'm going to keep moving this point along until the points become 1 and we have a tangent line, right? Well, in that case, what I'm doing is I'm letting the x approach c. The x is getting closer and closer to c. All right? So that's the idea there. And so how I'm going to write my limit on this one is I'm going to say find the limit as x approaches c. Because as x approaches c, the distance between those two things becomes 0. Okay? And that's what we call the limit definition of a derivative. Okay. Now I guess the only difference will be is that for this one we're actually finding the value of the derivative at a specific number in this case. Whereas in the other limit definition that I shared with you guys, we're finding the derivative with just x's, so it's all variables. But in this case, you're actually finding the limit at a specific number, which we're calling c. Okay? And so that's pretty much the gist of it. Let's go ahead and jump in and see how this thing's going to work out for us. But actually, before we do, I think make sure you guys do have this written down in your notes. And if I were you, I would title that the alternative form And what is it the alternative form of? That's the alternative form of the limit definition of a derivative. And that's it. So let's go ahead and do some sample probs to kind of see how to use that one. A little bit different than the others. Not a lot different, but a little bit different. So let's start off with something like this, I guess. So example 1. Let's say I had f of x is equal to x squared minus 3x, and I wanted to find f prime of 3 using the alternative form. Of the limit definition of a derivative. All right. So now, just so you guys know, we don't have to use the alternative form. I could find the derivative of this using our regular limit definition of a derivative. And when I'm all done, all I have to do is plug 3 into my answer, and I'll have the answer. So the other way that we have works. Okay, it's just that this way, it's kind of like you can plug the number in at the same time. But honestly, there's a way you could do that with the other one as well. I didn't go over that, but we don't need to do that right now. But anyway, let's go ahead and begin. So how do we use this alternative form? Well, the first step is I want you guys to find, remember our last step? Remember last time was find f of x plus h first? Well, in this case, I want you guys to find f of c first. Okay? Now, this number right here, that's your c value. So I want to find f of c. So I'm going to take my function, and I'm going to plug 3 in. That's going to be 9 minus 9, and that's 0. Well, that's kind of interesting. All right. F of 3 then equals 0. All right. Now the next thing that we do is we're going to plug everything in to our alternative form of the limit definition of a derivative, which is this. The limit as x approaches c of f of x minus f of c over x minus c. Okay, so let's go ahead and do that. So first of all, we're going to write the limit as x approaches c. Now, what did we say c was? C was 3. Next, we have f of x. That's just the function. So that's x squared minus 3x minus f of c. That was this thing. Now, f of c means f of 3, and that was 0. And then finally, we have x minus c on the bottom. So you have your c goes here, c goes here, f of x goes here, and f of c goes here. So there's our setup. Okay. Now at this point, what we're going to do is we're going to simplify the numerator. And for these problems, at least, it's a little bit easier to simplify the numerator for this one anyway. It might always be simpler. We'll see. We'll try a few of these and see how they pan out. But anyway, by just combining these, if you take away 0, nothing happens. So I'm just going to leave it as 0. So there's that. So instead of simplifying the step that has a lot to it, on this one, I think the one that has a little bit more work involved is the actual removing the discontinuity. And the way that you're going to remove the discontinuity on most of these problems is you're going to factor and cancel. Actually, you could use L'Hopital too if you wanted to, all right? Because as you guys can see right now, if I did direct substitution, I'm going to get 0 over 0. But personally, I think I'm just going to go with the factoring method. But you could use L'Hopital, just so you know. So for the factoring method, I could take an x out of the top. And by taking an x out of the top, those can cancel out. And that has removed the discontinuity. Okay. Step 5, we're ready to do our direct substitution at that point. So I'm going to plug 3 in here, and the result will be 3. I'm all done. All right, so kind of similar, a little different. Step 1, find f of c, so plug the number they give you into your function. Step 2, use the alternative form. Step 3, simplify that. Step 4, factor and cancel to remove the discontinuity. Step 5, do direct substitution. Now, just to remind you guys, back in Unit 1, we solved this problem in a much different way. I want to remind you guys of how we did it, but that's not what we're doing today. But I don't mind you guys doing this also, in addition to the stuff we've already learned, to kind of just stay fresh. So how did we do this in the past? If I asked you to find f prime of 3 in the past, what would you have done? Well, the first thing you would have done is you would have found the derivative, which is 2x minus 3. And then you would have plugged in the 3. And that would give me 6 minus 3, which is 3. And that's the answer we got just now, but we did it in a very different way. Okay? All right, so I'm going to let you guys try one of them. So here's one for you. Let's see, I gave you guys y equals x squared plus 3x minus 2. And instead of using y, I guess I better use f of x just so we don't get too confusing here. And let's say I asked you guys to use the alternative form to find f prime of 2. Okay? So let's go ahead. We'll kind of treat this one like a guided practice. So in other words, I'm going to let you guys do one step at a time. So pause the video here and see if you guys can do step 1. Okay, so step 1 was to plug 2 into the original function, and by doing that I get 8. So f of 2 equals 8. Go ahead and pause the video here and try to do step 2 now. So step 2 is to plug everything into your alternative form. You're going to put your c value here and here. You're going to put your f of x here, and you're going to put your f of 2 here, or your f of c, we could say that also. All right, let's go ahead and do step 3. Now step 3 is pretty simple. It's just going to be to simplify. Now in this case, all that means you're going to do is do the subtraction that's in the numerator. So negative 2 minus 8 is 10. So I'll just do that one with you guys right now because it's honestly not really worth pausing the video over. Okay, now we get to move on to step 4. Now step 4 is where we're going to remove the discontinuity, and that requires you to factor. So go ahead and pause the video here, see if you can factor and cancel to remove the discontinuity. Okay, so if you factored x squared plus 3x minus 10 correctly, you would have gotten x minus 2 and x plus 5. And these will cancel. And that would leave us with this. So that's the end of step 4. And now I want you guys to go ahead and pause the video here and do step 5, which is to do direct substitution and find your answer. So for step 5, all we do is plug it in. You get 2 plus 5, which is 7, and we're all done. Okay? Now, if you want, just for the heck of it, you can also check your answer doing the old school method. Okay, so in other words, you could just find, okay, well, what's f prime of x first? That would be 2x plus 3. And then you can plug in 2, and you get 4 plus 3, which is 7. So that's our old school method. And yes, usually that's what we're going to do, but we do want to know how to do it with this alternative form also. All right, well, let's go ahead and move on to another type. We're just going to do a couple of the different types of functions that we've learned, just so you can see how to handle each situation. So let's go ahead and do a square root situation here. So suppose I gave you guys this. Let's say f of x is equal to the square root of x plus 5. And I asked you guys to find f prime of 1, and I want you to use the alternative form of the limit definition of a derivative. Okay, so step 1, we're going to find f of 1. So I'm just going to take my function. Actually, no, I'm going to change my number here because I don't like 1. It's not going to be a nice number to work with. I guess we could do it, but I think I want to keep things simple on our first time around. So let me change the number. Let's say I wanted to do f prime of 4. Let's do that instead. You guys will see why I picked that in a second. So I'm going to plug 4 in here for x. 4 plus 5 is 9, and 9 is 3. The square root of 9 is 3. So there we have it. That's why I wanted to change my number. I didn't want to end up with some weird square root answer. I wanted a nice number. All right. Step 2, let's do our alternative form of the limit definition. So it's going to be the limit as x approaches what? 4. That's the c value. And then we have our function, f of x, which is x plus 5, the square root of that, minus our f of c value, f of 4, which is 3. And then the bottom we have x minus c, which would be x minus 4. All right, now we have one of these situations where we have that square root. And what do we do when we have square roots? We multiply the top and the bottom by the conjugate. Okay, so sorry, I had to go back and fix something, but this is what you would have. You'd, after multiplying both the top and the bottom by the conjugate. And now we get to actually go through and do our multiplication. So let's see what we get. So if you were to multiply this one by this one, you're just going to get the same thing. It's just that it won't have the square root on it anymore. And then this one times this one is going to make negative 9. On the bottom, we have x minus 4. And we also have this big old clunky thing right there. All right. So that's the beginning of step 3 there, where we start simplifying the expression. And this is 3a, right, where we multiply the top and the bottom by the conjugate. So now let's do step 3b. 3b is where we're going to combine our like terms in the numerator. All right. And then after that, we can go ahead and remove the discontinuity. These will cancel out. Boom and boom. And that's actually step 4. So for step 4 then, after canceling that little thing out there, we have 1 over the square root of x plus 5 plus 3. Okay? And then for step 5, we're just going to do our direct substitution. So you're going to plug in 4 and see what you get. So if you plug in 4, you're going to get the square root of 4 plus 5, which is square root of 9. Square root of 9 is 3. And 3 plus 3 is 6. So you end up with 1/6 by plugging that in. Now, once again, if you guys wanted to, you can go back to the original problem and check your work doing it in the old school way that we learned. So what was the shortcut we learned for finding derivatives of square roots? Well, the shortcut was 1 over 2 times the square root itself. And you multiply it by the derivative of the inside. but in this case, that's just 1, so you don't really need to worry about that. And then if you wanted to find f prime of 4 specifically, you would just plug in 4, and that's going to give me 1 over 2 times the square root of 9, which is 1 over 2 times 3, which is 1 over 6. So it's the same answer using the shortcut method. You can check your answers using the shortcut, but make sure you do know how to do this stuff. All right, I'll throw one at you guys now. Let me toss one your way. Let's suppose you guys had this. All right, go ahead and pause the video here and see if you guys can find f prime of 9. When you unpause the video, you'll see the solution. So I was working through this problem, and then I came up to this point, and I realized you guys might get a little stuck here. But the reason why is because it's actually a little bit of a combination of this new stuff, which is square roots, and also something else we talked about earlier in this lesson. So as you'll notice here, you can't really do anything beyond this point, right? Or can you? Check this out. Nothing cancels, but what if I were to factor a 4 out of the top? All right, so I'm going to stop there, and I'm going to encourage you guys to pause the video again, now that I've kind of helped us get over that hump, and see if you can finish it now. And then when you unpause it, you should be able to see the rest of the solution. All right, and so there's our final answer there. So after taking out that 4, the x minus 9's cancel out, which leaves us with this. So we've removed the discontinuity. And now we can just go ahead and plug our 9 in. And when you simplify all that, you end up with 1/3 as a final answer. All right. What else can we chat about here? How about, let's do one more. And after that, I think we'll have covered our grounds pretty good on how to handle a lot of these different types of problems. Let's go ahead and do a rational expression. So let's say that I told you guys that f of x is equal to 1 over x minus 2. And I asked you guys to find what is f prime of, let's say 4. There we go. All right, so step 1, find f of 4, right? And I end up with a half. Step 2, plug your stuff into the limit definition of the derivative. And so now we're dealing with the old rational expression situation that we've dealt with a few times now. So to solve these problems, the first thing we're going to do is we're going to take these little denominators, like the 2 for instance, and multiply every fraction by that denominator. The reason we do that is because that way it cancels that, and then we're left with one less fraction than we had before. So let's see, that leaves me with the following. Okay, and now we're going to repeat that, because now I want to get rid of that denominator. So I'm going to multiply everything by x minus 2. And the reason I do that is because now these will cancel, and now I have another less fraction than I had before. So the goal is just to get rid of fractions, because they're kind of an unpleasant thing to have in a problem, right? So we have 2 minus 1, parentheses x minus 2, over 2, parentheses x minus 4, x minus 2. Okay. So step 2 is to write out your limit. Step 3 is to simplify. We're still on step 3 though, because now that the fractions are gone, we're going to go ahead and do the old distribution and combining process here that we usually do. In this case, those 2's can be combined together to make 4 in the numerator. And I believe this is something we saw once or twice back in Unit 3 where, okay, fine. These two things here look like they should cancel, but they're not quite right because one of them's backwards. And so we talked about what to do with that back then. And the strategy for dealing with that is we can go ahead and flip them around so that they match if we do a little trick here. I'm going to flip this one around on top so it matches the one on the bottom, and I'm allowed to do that so long as I put a -1 in the front. Because basically what that ends up doing is changing the signs when you do that. Now you can cancel those out, and you're going to be left with -1 over 2 x minus 2. All right, so that was step 4, by the way, where we flip it around, put a negative so we can cancel, and that's removing the discontinuity. And so now we're ready for step 5. And in step 5, basically, we're just going to plug our number in. And that's going to leave me with -1/4. Okay. Now, for this one, you could, if you wanted to, you can go back and double check with the shortcut method. You could do this. The shortcut method for this, probably the one that'd be easiest for you guys to remember is low d high minus high d low, draw a line and square below. But honestly, that shortcut method really isn't so short. And so you could do it if you want, but I think we'll go ahead and just stick with what we have there. So let me go ahead and throw one of these problems at you, and I think we could probably call it a day at that point. We've gone over quite a few different situations at this time. So here we go. Let's say I gave you guys f of x is equal to 1 over 5x. And I asked you guys to find what is f prime of 1. Pause the video. Go ahead and give it a try. See what you guys can do. Okay, and so I stopped it at step 3 again because you guys might notice there's another little funny thing going on there. But if you went ahead and took it all the way in, that's awesome. But anyway, I'm going to stop here. So here's your f of 1, it's 1/5. Here's your setup. And then if you multiply everything by 5x and then multiply everything by 5, you should end up with something that looks a little bit like this now. Okay, so on the numerator, you should have 5 minus 5x. And in the bottom, you should have a 5 being multiplied with an x minus 1 and also with a 5x. Okay, so what do we do now? Well, first of all, you'll notice we can factor something out of the top, can't we? I can take a 5 out of there. That's going to leave me with 1 minus x. And as you guys can see, I can cancel these 5's out, but that's not removing the discontinuity. Remember, the discontinuity is the one where if you plug in the x, it makes a 0, and that's right there. It's that x minus 1. So I really want to get rid of the x minus 1. And as I told you guys before, we can go ahead and change this one around if you want to. Just make sure you put a -1 in front of it if you are going to do that. And now we can cancel those out. So now we have the limit as x approaches 1 of -1 over 5x. And then from there, we're going to go ahead and plug in our number. And we end up with -1/5 as our final answer there. All right, I think we'll stop there. But just, yeah, there's some interesting little situations that pop up sometimes where you got to factor or flip terms around with a negative. But other than that, I think we've kind of covered all of our bases and we should be good to go. So I'll wish you guys well on your homework and we'll see you next time.